Welcome to the Real Python Podcast. This is episode 259. Did the design patterns learned in other programming languages translate to coding in Python? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. Christopher dives into an article that tackles popular object-oriented design patterns from the famous Gang of Four book. These patterns offer solutions to common coding problems, but as Christopher explores, Python often doesn't even have the problems these solutions try to fix. He discusses common design patterns and the simpler, more Pythonic ways to achieve the same goals. We also share several other articles and projects from the Python community, including an exceptionally robust news roundup, running coverage on tests, exploring expert generalists, previewing template strings from Python 3.14, quizzing your knowledge about fstrings, and a project to calculate the complexity of your Python code. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
So, take a week off and oh my gosh, the news just piles up, huh?
Yeah, I think that's my fault for complaining about a news drought or predicting one, yes.
Well, here it comes, the rainstorm.
Yes. All right, so we're diving straight in. Since the last time we did a PyCoders episode, Python 3.14 Beta 4 got released. Then that news got subsumed by Python 3.14 RC1 coming out.
There we go.
The hope is to have one more release candidate in late August, and then the full release coming in early October.
Time to test your stuff.
Yes, I don't know, it seems to be happening faster.
It does.
But if I remember correctly, last year there was some rough spots with the release candidate, so I do wonder whether they've widened the window a little bit to try and prevent that from happening again. Or it could just be I'm old and things happen faster than I expect them to. So, not to be outdone, the alternative interpreter PyPy also had a release, version 7.3.20. It's mostly Bugfix release with some performance improvements thrown in there for good measure. Still on release news, although Textualize the company is no more, that hasn't stopped Will McGugan and friends from busily working away. The popular TUI toolkit Textual, try saying that 3 times fast, they released version 4. The big new feature for this release is the ability to efficiently stream markdown content, which is helpful if you're hooking your code up to an LLM, which is exactly what Will did with it.
Yeah.
He's announced a new tool named Toad, which is a TUI for talking to LLM APIs.
Yeah.
There seemed to already be some buzz about it, that some folks who don't like the command line interfaces are already looking at a better way of doing things. Next up is the UV Package Manager, released version 0.8. This version concentrated on the UV Python install features, which were previously only available in preview. So a bunch of the stuff that required the preview flag no longer does. Now, the next chunks, I've got a Django theme for you.
Yeah.
Starting with a release announcement, just for consistency, 5.2.4 came out. It's fixed a couple of regressive defects from 5.2.2, so this is why it's really only a 5.2 fix. And beyond that, the Django project site, which is where you download Django from and has the documentation, tutorials, all that kind of good stuff, they've added a new section called Django's Ecosystem. This page has a list of resources for learning Django and a really comprehensive list of some of the more common third-party packages out there that you might use. This is kind of neat. It's nice to have it all in one place. And it's kind of also neat because they were talking about this at the conference we were at. And then to see it show up, it was like, oh, they said they would do it and they did it. Look at that. Good for them.
And they definitely didn't take too long to get it done. That's
It did
good.
not. So,
Yeah.
and still on the Django topic, it recently celebrated its 20th birthday. There's been a lot of stuff around the web on this topic. In the show notes, we're going to link to Simon Willison's blog post, which includes a reposting of a Django history talk that he gave on the 10th anniversary, as well as some comments and extra stuff in the article. So one more year and Django can drink legally in the United States. So I think I'm going to go off and buy drunkendjango.com and see if we can have some fun with that next year. So
have some unicorns and Pegasuses and whatever.
There you go. Drunken unicorns. That sounds like a good punk band. All right. We're almost there. The videos from PyData London got posted on YouTube. So there's a lot of good talks there to check out. Topics include narwhals, climate models, bunch of LLM and deep learning stuff, and loads more. So if you want to go watch some talks, there's a link for you. And then the last bit of news is PEPs. First, PEP 792 got accepted. That's titled Project Status Markers in the Simple Index. This PEP has to do with packaging and its associated metadata. Like with most packaging PEPs, it isn't really tied to a release. It's published in the hope that all the various tools out there just will become compliant. And then we've got PEP 800, which recently got added. This one is titled Solid Bases in the Type System, and it proposes a new class decorator for the type system. There are situations where inheriting from two classes can be problematic. For example, you shouldn't inherit from both int and string and expect things to work. They really aren't compatible.
Yeah.
The type system doesn't currently have a way of discovering this. And so this proposed decorator declares that a class is a solid base, with the idea being that any given class can only inherit from a single solid base at a time. Take all of that with a grain of salt, as it's part of the typing system. There's a good chance I just didn't understand it.
Solid.
And well, Mr. Bailey, I'm sorry you didn't get a chance to speak this week. I think that's it that's all the time we have. Thank you and good night.
Yeah, thanks for the Real Python News Show. We'll see you in a couple weeks. All right, yeah. Well, I'm ready to dig into some topics. There's kind of some themes happening that are going to repeat throughout. The first piece that I have is from Hugo van Kemenade, and he has a blog that's hugovk.dev. The title of it is Run Coverage on Tests. Basically, it's that, recommending that you run coverage on your tests. I was slightly confused by simply saying run coverage because I think there's some choices there. There is a popular package called coverage.py. There's some built-in tools, and he actually has a screenshot at the very end of the whole piece that shows that he's using a tool from Sentry that is called CodeCov, CodeCov. So there's a variety of ways to do this. And just to kind of clarify for people, because I think it's confusing, there's a lot of terminology that gets thrown around there. And what does coverage do? And I thought it might be helpful to kind of go through this. So I just going to read the first paragraph from the read the docs for coverage.py. Coverage.py is a tool for measuring code coverage of Python programs. It monitors your program, noting which parts of the code have been executed, then analyzes the source to identify code that could have been executed but was not. So coverage measurement is typically used to gauge the effectiveness of your tests. It can show which parts of your code are being exercised by tests and which are not. So it's kind of this partnership between the tests that you've set up and then a tool that then runs the code through that and can verify. And typically this is, thrown out of like a percentage number. Okay, we got, 100% coverage or something in there. In his post, he's providing a couple examples of why you should check that your tests are properly configured and actually run. The first one, which is interesting, which I can agree with, in today's world, it's easy to be in a hurry to do things, and you might do the copy and paste thing. A lot of tests look very similar, and so they'll have very similar layouts. And you go ahead and you copy and paste the test inside there, and you go in and start modifying elements that are below the initial definition of the test. And whoops, you forgot that you didn't rename the test method. And so now you have two test methods that have the exact same name. So only one's going to be called, so one's never called. He links to a couple of pieces from Ned Batchelder. The first is actually from 2011, and it's kind of like a play from an IRC channel, true story, back and forth. So he's saying two test methods with the same name by accident. So one is never called. The other person's, oh boy, one of the test modules I was ignoring, sure enough, was a test that wasn't being run. I hadn't thought of that before. Yay, coverage, says Ned Bat. And so the other piece is from 2019, and I'll just read a quote from it. There's a common idea out there that I want to refute. It's this: when measuring coverage, you should omit your test from measurement. Searching GitHub shows that lots of people do this. This is a bad idea. Your tests are real code, and the whole point of coverage is to give you information about your code. Why wouldn't you want information about your tests? Some good insights there. A couple other links are included also. Coverage will find code that isn't run. That's kind of the idea of it. This clearly shows up as not run code. It'll actually give you the line numbers in the test report and the coverage report that you get. He suggests adding a potential rule if you're using the tool Rough. Their rule is called redefine-while-unused. And so it checks variable definitions that redefine or shadow unused variables. And so the second example that he's giving in this short piece is less obvious. It is involving a generator. And in this particular case, the generator is run in an earlier chunk of code. And so all values are consumed in a for loop, and basically the generator is exhausted. So by the time the assert statement that is to be tested, it's not run because there's no values to test in the testing for loop. But a code coverage tool would find that assert statement isn't being run in the other further for loop. And so his solution in this particular case is to use a list instead of a generator. Again, the piece is short and to the point, and I think it's kind of a neat idea, sort of quickly explaining the idea of like how these two things are married and work together. And again, some common pitfalls you might fall in. I don't know what your experiences are here, Chris.
I've made both those mistakes recently. So, yeah.
Okay. Yeah.
About a week after I linked to that article, I made the that exact copy and paste error thing. And I'm with certain libraries, I'm obsessive about my coverage level. And I was like, why did the coverage number drop? It shouldn't go down. I've added tests. And then I looked at it, and sure enough, one of the tests wasn't being run. I'm like, oh, well, that's why the coverage number went down. And it was that exact same copy and paste problem. Yeah.
Yeah. I mean, structurally, they're all so similar.
Yeah. Test code tends to be a lot of copy and paste. Yeah.
Yeah. I think another suggestion that was in there was parameterizing things so that you're kind of able to run things. This is something that PyTest has featured over the last several years, where you're not having to just repeat the code per se, copy and pasting it. You're able to run the code across different situations, and maybe that might be another way to approach this.
Yeah, the PyTest folks, the people who are religious about PyTest seem to think that is a good answer, and I kind of understand it. I actually prefer the very linear test code because
complexity of it. Or
yeah, as much as like I get it, I don't think of maintaining my tests the way I maintain my code. And I don't know whether that's right. I'm sure somebody will leave a thing in the comments that says I'm horrible, but I find I want that linear. I want that. Like, these are the 5 things. Okay, now I'm going to change a variable. Now I want to do these 5 things. Because I find frequently when I try to do fancier things in the tests and I have loops, what ends up happening when something fails is now I've got to add a bunch of code that tells me where in the loop it failed. Because if the loop is unrolled, then it got to line 57 or it didn't get to line 57. Whereas if I've got a loop over a whole bunch of testing variables, now I've got to say, oh, well, okay, this didn't assert. Well, what was the conditions when it didn't assert? And so I have a preference towards that sort of linear stuff, but
that makes sense.
Could just be me being old school. So
I think it would lead to readability in some ways, and kind of like
it leads to much longer code is the problem, and I think that's what and
the longer novel.
Yeah, well, and it's funny, right? Because like if a junior developer came to me with this as their code in the actual code, I'd be like, no, don't do that. But in the tests, for me at least, that's the exception. I'm sure there's people who are better at it out there than me that are cringing right now, but so be it.
Well, I think that gets us into the next topic here, actually.
There you go.
Talking a little bit more about design patterns and thinking about that stuff, which is going to be kind of a bit of a theme. Are you ready to dig into your first topic?
Yeah, it's an article by Racy Chan, and it's called Design Patterns You Should Unlearn in Python. So if you're not familiar with the term, a design pattern in software is a reusable approach. It's typically language agnostic, so it's like a higher level thing. And one of the more common ones you'll come across is a singleton, which is a way of making sure that you only ever instantiate a single copy of a thing, like a connection resource to a database or something like that. There's a very popular book out there on this whole topic called Design Patterns, Elements of Reusable Object-Oriented Software, and it's by Eric Gamma, Richard Helm, Ralph Johnson, and John Vlasides. And these are sometimes known as the Gang of Four, so you'll hear this as they're the Gang of Four, or you'll hear the book referred to as the Gang of Four pattern book. So this is a common one out there. It's a good book. It's quite comprehensive. But some of the things in it are actually sort of overkill in Python. And that's really the premise of Racy's two-part article. So a lot of the patterns in the book are necessary for heavier languages like C++ and Java, but some of Python's higher level approach means the patterns are not really necessarily the best idea. So that singleton I just mentioned, Racy starts with that as an example. If you look for Python articles on the topic, you'll find deep dives and you'll find clever things like using dunder new and all this other stuff. And while interesting, it can be problematic. Earlier versions of C++ had no concept of modules and little in the way of packaging mechanisms. So the singleton really was a way of getting around this. Well, Python has a module level variable, and this can often solve the problem. Your singleton is the variable set or the variable's not set. You're using it to the first time it's empty, it's none, set it. And if it isn't, you're done. And so you can get rid of a lot of this extra machinations that were necessary in other languages. So another common pattern is something called the builder. This pattern it attempts to simplify the creation of complex objects using a step-by-step approach. So this is like a factory, but even bigger. So the idea is you have a builder class as well as the class that's being the built. So the builder is a instance of a factory itself. So the builder has a bunch of setters on it, which you call configuring that you need to, and then you call the build method, which actually returns the class you're after. So Java and C++, their constructors don't have default arguments. So this can actually help if you've got a really complex object with a lot of stuff in it. But Python's got defaults and keyword arguments, and so you can set a whole bunch of that just by specifying it in dunder init. And if you absolutely have to use this pattern, due to having a lot of complexity, well, Python has something else that Java doesn't, first-class functions. So instead of creating a builder object, you could write a factory function to solve the same kind of thing. So again, this is one of those places that's sort of it's an overkill thing, and you can end up with a lot less code in Python if you want to take that approach instead. Part 2 of the article goes on to cover the flyweight and prototype patterns. The first is a way of dealing with memory constraint problems, and the second's a way of dealing with object implementations used by frameworks. So if you're from the Java or C++ world and you want to know how to write more Pythonic code, or if you're from the Python world and you want to learn a bit more about the concept of design patterns from an anti perspective, then these two articles are definitely worth taking a read.
It's time to shine a spotlight on another Real Python video course. Python has a complete set of built-in exceptions that provide a quick and efficient way to handle errors and exceptional situations within your code. And this course is titled Working with Python's Built-in Exceptions. The course is based on a Real Python article by Leodana Esposo Ramos, and in the video course, instructor Joseph Pert takes you through what errors and exceptions are in Python. You'll understand how Python organizes the built-in exceptions within a class hierarchy. You'll explore the most commonly used built-in exceptions and learn how to handle and raise built-in exceptions in your code. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the technique shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. My second piece, I got very interested in this one about kind of a new definition of I don't know if you want to call it a role or a type of the anti-specialist, if you will, in some ways. It's a piece by Martin Fowler and a couple of other authors. They're all from an organization called ThoughtWorks. And computer systems and software generally continue to get more and more sophisticated, and there's a trend to value those with deep system and software knowledge, these sort of deep specialists, and organizations seek out these specialists. But there are factors to considering how to kind of put a team together and thinking about what else you should think about as far as including with the team. And so I'll be reading some quotes from the piece. Folks that only work in a single technological neighborhood are at the constant risk of locking themselves into a knowledge silo, unaware of many tools that could help them in their work. But increasingly, we see the software industry pushing for increasing narrow specialization. Over the past couple of years, we have started to resist this industry-wide push for narrow skills by calling out this quality, which we call an expert generalist. Why do we use the word expert? There are two sides to real expertise. The first is familiar with depth, a detailed command of one domain's inner workings. The second, crucial in our fast-moving field, is the ability to learn quickly, spot the fundamentals that run beneath shifting tools and trends, and apply them wherever we land. As an example, from software teams, developers who roam across languages, architectures, and problem spaces may seem like jack of all trades, masters of none, yet repeated dives below surface differences and help them develop durable principle-level mastery. Over time, these generalists can dissect unfamiliar challenges, spot first principle patterns, and make confident design decisions with assurance of a specialist. Being such a generalist is itself a sophisticated expertise. The idea here is that they talk about kind of the shape of employees, that there are certain people that are, these deep specialists. They're kind of like a spike pointing directly down and deep into a particular subject. Whereas there are other people that have a shallow knowledge across a whole bunch of domains, but then have legs that go down and sort of a T shape into certain areas. And they might have, multiple legs of areas that they're interested in with different widths and so forth, but they're also very good across the board on all sorts of stuff. And so they kind of dive into the characteristics of this expert generalist.
The agile space is a little obsessed with this. There's a lot of you want T-shaped people on your teams.
T-shaped people? Okay, so that's a term that is not as familiar to me, but you've heard it.
And a big part of it is, so if you've got a small team with like say 5 or 6 people on it, and you've got a DBA on that team, well, some weeks you're going to have enough work for the DBA. And some weeks you're going to have too much work for the DBA, and other weeks you're going to have not enough work for the DBA. So having a few T-shaped people means, when the DBA's got a light week, well, they can help out with something else because they're T-shaped. And when they have a heavy week, then somebody else who's T-shaped can help out with the DBA.
Okay.
And then it gets crazy. I've also heard pie-shaped because they've got 2 depths, and bridge-shaped, which is sort of like the unknown number of posts as you go along.
Pillars there, yeah.
Some of it is a little aspirational.
Yeah, I can imagine.
But it's an interesting principle.
Yeah. They wanted to dive into how do we describe this type of person and what are some of the characteristics? And one of the first characteristics is curiosity. When they find something new, they want to discover much more about it instead of immediately putting something into action. They want to build up some familiarity. I find this as a teacher. I always think about, as I'm learning a new subject, how would I explain this to someone else? It's almost kind of like a rubber ducky style. I know that people use that as a way of kind of talking through code problems and so forth, but you could do it also as a way to explain stuff. I know you have that relationship a little bit with your wife. I have that with my wife, which is kind of nice. She puts up with me talking about technical stuff. And so making sure that someone else can understand the answer. And I like this last line from that section. There is an art of asking questions to find deeper answers without leading the witness. This idea of how can you find out more without having assumptions already in your head about it? And that's something that I feel like I'm one of these T-shaped people in some ways, and curiosity is definitely one of those things. I'm always fascinated to learn more and dig into stuff. And I'm always a very wide researcher. I always kind of grab all the different stuff if I'm having to learn something about some particular idea or new concept. I'll find resources across the board. collaborativeness, which is a word that keeps getting red underlined in all my spell checkers because it doesn't seem to be an actual word that they've invented here. But this section talks about, again, that shape of the person's knowledge, how many specialists are like a vertical spike diving deep into the singular topic. And Generalists has got that more T-shape with a wide shell across the top. You can't learn it all, and learning how to combine the knowledge across a team is this sort of collaborative key. Expert generalists are not afraid to ask for help. Having collaborative curiosity is key to it, and having this humility, which I agree, this idea of, okay, find the people on your team that you can pull into the situations and learn more from, championing their talents and pulling a lot of that knowledge in. This is one that I also think is a really strong idea, which is customer focus. Instead of using curiosity to chase the next shiny object and learn that particular thing, the person takes unfamiliar tech and wonders how it will help the customer. They want their users of this technology to excel. And I had an issue with this at a couple organizations I worked in. The leaders were really interesting. They really wanted to make impressive software projects that others would look and say, wow, isn't that impressive? I was sitting there thinking, yeah, but who the hell's going to use it? I mean, otherwise you're just making an art project. If no one's going to use it, it's just going to sit behind glass. And, it makes me think about how sad I get when I go to somewhere like the Hard Rock Cafe. So no one's ever going to play that guitar again.
It's a common problem with engineers. Like I think I suspect it goes to almost any craft, right? Like the craft starts to become a little bit for craft's sake. And the case of software, ultimately you're trying to build something that other people will use. And this, I think, becomes twice as bad in the software world, because if we use our own software, we go, oh, well, I use it all the time, so it must be usable. And
yeah, I made it for myself.
And
I'm the customer.
Stepping back and going, oh, well, maybe, you know what? Maybe having 75 command line options isn't the best, most approachable choice, right? But if you use it all day, it's hard to sort of separate from that.
Yeah, I just feel like I don't want to make museum pieces.
Yeah.
I want to make people's lives, easier with tools. And also, that's something I've found out about my personality too, that I really like making things for other people and solving their problems. And I have a hesitancy of whatever it is, outside of wanting to learn something new, of building lots of tools for myself. I don't know what that is, but it is something that I find an interesting part of my own kind of personality there. The next section is about favoring fundamental knowledge. This is where it digs into the idea of learning patterns, kind of going back to what we were just discussing there. Principles versus specific tech. Tech's going to change. I think of JavaScript libraries when I was starting to learn some of them 7 to 8 years ago, and it was always the next person would say, oh, don't learn that old stuff. That was like 6 months ago. Learn this new thing. And it was like, And so it was a little hard to kind of get my footing. And that was one of the things I liked about Python in some ways, that you could go to the fundamentals. You could go to there were pretty standard pillars across the libraries that I would see. And so that was nice. Core patterns. It's why we like to bring them up on the show. It goes a little bit further into this idea of blending generalist and specialist skills. It goes into that T-shape a little bit more. Having sympathy for related domains instead of diving headfirst deep into the new details, finding a sense of what works in this new subject. And then a little bit about when coming into a new team, listening to the established ways that a team works, and then thoughtfully introducing new approaches and not upending everybody else to say, hey, we're going to do it this way. And then they go into this whole area of, well, how do you find somebody like this? How do you assess expert generalists, like hiring, the career progression? How do you foster that sort of stuff? And growing generalists. There's another little paragraph I'll read from it. One proven aid is the language of patterns, reusable problems, solution pairs that capture the core principle without the brand labels. That's why we believe investing in exploring, distilling, and sharing such patterns so the industry conversation can shift from which tool should I learn next to which underlying principles and patterns must I master. They have an example workshop where they're breaking silos and sort of building partnerships and connecting in this particular example, they had like an application development section, a data engineering section, and DevOps sections, and figuring out like, okay, well, in that sort of example workshop, how would they work across those things? The last section digs into how expert generalists still need specialists, which I think is true. Again, you're always going to need some subject matter experts on these particular things and people that are really good at these particular skills, but there always kind of needs to be a balance. They dig into a section about generalists in the age of LLMs and the ability to use the technology to get familiar with a new area, rapidly answering questions about a new domain. Again, knowing patterns and fundamentals, this helps. It's why the common refrain I hear against trying to learn through LLMs by having LLMs do all the work and not knowing what the questions should be, it's kind of the problem we have. I saw this thing on Blue Sky that I mentioned to Chris before we started about how a teacher was trying to deal with students that were needing to learn how to write a paper. And the teacher said, I'm okay with you learning how to use an LLM, but I want to flip it on its head a little bit. I want you to have it write this paper or this piece, but then I want you to research everything that it did wrong. Like, where did it make mistakes? Potentially, why did it make those mistakes? What is a hallucination? And they kind of grow this tendency then to be able to see where an LLM kind of makes mistakes inside this, why they shouldn't trust it blindly, and kind of make them a little more, just across the board educated across what the tool is. It's so funny to see all the different mistakes get bubbled up in our industry. And I wondered about that as far as like learning to program. I know that when I talked to Simon Wilson, that was one of the first things that he was saying to me, is that he would try to find it to make mistakes for him and try to find out where is that sort of borderline and get comfortable and noticing those mistakes. But I wonder about that as far as learning to program, like how you could apply some of these techniques to that. And the last section is why organizations need people like this, breaking skill boundaries and creating interactions across gaps. And then a collection of takeaways, sort of key traits and stuff like that we've repeated there. So it's interesting. So this is something that is championed in the agile world, you would say?
The T-shaped thing's a big part of it. It's, from a pure project management standpoint, having people with broader skill sets, it makes it easier to schedule.
Okay.
Take a classic construction example, right? If you only know how to use a hammer and I only know how to use a screwdriver, anything we're building, like,
right,
if there's no overlap. Whereas if we both know how to use it, then we can both do things, right? The challenge in the software world is there's this depth of knowledge that is necessary to do certain tasks. So in the agile space, a lot of it, I think, comes more, at least in my experience, a lot more of it comes more from the side of, are you willing to?
Okay.
More than, right? So, and often when I teach this, I talk about sort of the tech stack, and that example I used earlier, as a DBA. Well, DBA isn't going to look for breadth as being the DBA and the front end design guy, because in all likelihood those are very far apart skill sets. But the DBA picking up a little bit about how ORMs work, and so being able to help out the back end folks on that. So if you think of that sort of stack, wherever you are on that stack, go a little above and a little below where you are in the stack, and those are not that far from the skills you have, but it makes you a lot more useful to the team.
Yeah.
The other thing I find, and I think because this is sort of why it's popular in the agile space, this stuff tends to be more important in startups, because as you're pivoting, as you're trying to do something, what you're doing next week may not be what you're doing this week. And so there's got to be that willingness to, well, that's not my thing, but I'll do it for a while. Let's contribute, right? The other, I've hired developers who don't speak the language that we're coding in.
Yeah.
As long as they understand that that's what they'll be doing when they come on board my team, I'm okay with that. And because the couple months of ramp up time of doing that and getting a good developer is much more valuable to me than I've got someone who knows the language really well, but isn't a good developer, right? So that's always a bit of a cost trade-off. And in fact, if you were looking to become more of a generalist, I think one of the ways to help flex that muscle, train that muscle, is go pick up another language, right?
Yeah.
Right. So
that's definitely something that's focused across this, like not only learning design patterns, but like being able to recognize them in other languages.
Yeah. Well, and something as simple as the vocabulary, right? So you're not going to understand the subtle difference between a pointer and a reference until you've actually been working in languages that use both of them, right? So picking that, there's nothing like having to manage memory yourself to be grateful for a garbage collector, right? So that there's value in that experience.
Yeah, cool. So what do you got next for us?
I've got a real Python tutorial and course. The original tutorial was by Leodanis Boltso-Ramos, and I converted it myself into a video course. And the topic is the new T-strings in Python 3.14, which we've mentioned a few times on the show before.
Yeah.
T-string is like an F-string, but with a T in front of it, hence T-string, and instead of the F. The internals, the stuff that's within the string, are more or less the same. They interpolate values and do formatting and all that kind of good stuff. What's different is that instead of returning a string, a T-string returns an object, and that object is of the template class from the template lib module. That template instance contains the parsed portions of the inner string. So, for example, let's say you've got the classic hello name, where name is in curly brackets and it's going to be substituted with the contents of a variable. The F string returns hello Chris. Of course, now you got to wonder, am I being egotistical or am I being nice to my host? The F string returns hello Chris, which is the process string. What the T string returns instead is a template object that has two things in it. It's got the string hello and then a interpolation object. And that interpolation object represents that name thing I was talking about. It contains the variable name. It also contains the evaluation, which in this case would be Chris, and it's got some other odds and ends, which I won't bore you with. When you examine a template object, you'll find that it contains two attributes. The first, named strings, contains all those string parts that I just talked about. In fact, I kind of oversimplified. Hello name would actually have two strings in it, hello, and then an empty string, as in nothing comes after the variable. And then the second part of the template is named interpolations. And as you might guess, it might contains those interpolation objects, one for each of the curly bracket fields in your string. The tutorial and the course both start out by explaining the different ways of formatting string content in Python, then go to show you how the template interpolation objects are different and how they come out of a T-string. Of course, there's also the bigger question of why, which also gets covered. One use of T-strings is when you want to reinterpret a string template multiple ways. Say you're doing structured logging, where you want to log a human-readable message as well as, say, a JSON formatted message in your logging tools. By using a T-string, you can write a function that consumes the template and then produces the two different results. The tutorial and the course cover this and several other examples, along with details about how to work with the different parts of the templates, how you process them, how you interpret them, and all that kind of good stuff. So if you're itching to try out some new Python 3.14 stuff, or you just want to see why SQL injection sucks, then you've got a choice. You can either read this or watch the course and learn more.
Were you using templates in Django or
different kind of template? Different
type of templates, yeah.
It's the concept's the same, right? It's a placeholder string that has things replaced inside of it.
Right.
At the very generic level, you could consider what's inside of an F string as a template, right? I've got the string part and I've got the thing that gets replaced. It's a template.
Right.
Django's templating language is the same thing. Usually it's used for HTML, right? So you've got an HTML file that's got, they use double curly brackets inside of it.
Right. And
where you have those, it gets replaced with things. So the generic concept, in fact, it may cause confusion that they called this a template object.
Yeah. I think there's like several different uses of it. Yeah.
Also another one in the string library. So I do wonder whether the name overloading is going to be problematic. But in fairness to them, I don't know what else you would call it. So
yeah, but the template object that's been in Python, there were other sorts of uses inside there.
It's for templating, the same way F strings are for templating, whereas this template object is an output of a templated string. So
yeah, that's interesting. Yeah,
and it's all wired together, right? So the reason the F string and the T string have the same capabilities is the underlying parser. All they've done is really put in a hook. So the underlying parser runs, builds out these chunks, and then in the F string, it returns the comprised result. With the T string, it stops before that last step and returns the chunks to you. So it really is just kind of a hook into what was happening in the parser anyways.
I think it's like this is interesting food for thought, like how you would use this. It's definitely a different kind of animal in the way that it's created. And
this is definitely an intermediate kind of, right? Like I see this.
It doesn't quite do everything you wanted. I could tell that from the course.
Well, there's that too. Yeah, I wasn't even going to get into that, but there was a large debate on lazy evaluation as to when these things could fire or wouldn't fire. The primary use case I wanted for it requires lazy evaluation, so I got a little curmudgeonly, but I see this as being something useful for library writers.
Yeah, right. We're going to take this to a higher level.
So if you're writing a library and you're trying to make it easier for somebody else to use features inside of your library, then, getting them to pass you a t-string might actually be a good approach, right?
Yeah.
I think that's where you're going to see it rather than if you're writing a program, I don't know how often it'll pop up. The flip side of it, a big use for this really is for dealing with escaping of user input. So if you're accepting input from the user and you want to make sure that it gets handled properly, you build a function that processes the input as part of a template, and then you can make sure that it gets escaped, hence things like the SQL injection that I was mentioning. So that's going to be the use case, I think, most of the time. So
when this comes out on Friday, the tutorial is up, and the next Tuesday, the course will come out. So it may not be right there right away, but it's coming shortly after. So watch out for that coming to Real Python near you. All right, we're heading into projects, and let's talk about fstrings. For my project, I found this quiz created by previous guest Armin Ronacher, whose name's come up recently in our discussions about AI. But he created this quiz to test your knowledge about this related topic, fstrings, and the website is named the same as the URL, fstrings.wtf, which I think is funny. I didn't know there was a WTF domain. And the subtitle is basically, how good is your knowledge of Python fstrings? Questions reflect behavior as of Python 3.13. A couple notes here, because fstrings interpolate expressions inside string literals using curly braces to produce the formatted strings. There's a couple things you may want to think about. If you don't want any hints or any kind of help, maybe skip ahead 20 seconds. But there are a bunch of borderline cases that are head scratchers here, and don't forget that these fstrings and t-strings both feature the formatting mini language syntax, so maybe you need a refresher on that. So there's a lot of stuff in there, but did you end up taking it? I did okay. I didn't answer as well as I think you mentioned Heineck.
I didn't want to know. I'm perfectly happy being ignorant about my skill set. There's a cheat sheet that I've got bookmarked, and it tends to be what I go to all the time. So
yeah, the formatting mini language is hard to remember, like what single letter indicates what formatting thing and stuff like that.
Yeah,
but it's nice what it can do.
There's some overlap between it and the old style C style, so some of that makes sense to me. But then there's like places where you can put spaces and places where you can't put spaces, and So,
and then a part of it is the whole interpolation, the expression part of it. Like, what is it going to do with interesting other components there? But anyway, I thought it was a neat little project. We have quizzes across Real Python to test your knowledge as you're reading through and going through video courses. Definitely check those out. But I thought this one was kind of fun because I hadn't seen this approach before. So what do you got for a project?
My project this week is by Robin Quintero, and it's called complexipy. You might be familiar with the idea of a code complexity metric. They give a numerical value to represent how complicated your code is. This can be used in tools to highlight areas that need refactoring, or you can put limits in, say, like a pre-commit hook or something like that. One of the more common measures out there is cyclomatic complexity. There's different ways of doing this, but for the most part, it counts the number of independent paths through a chunk of code. So that means the more if-then-else clauses, the more you've got nesting, the higher your score, and a higher score is bad. This is golf. You want lower scores. Robin's project uses a different measure. It's called cognitive complexity, and the project's GitHub page links to a white paper that introduces this concept. The paper is behind a sign-up wall, but I was able to Google around and find another copy on the same site, which isn't behind the sign-up wall. So we'll link to that and see whether or not they clue in and take it down. Anyways, so cognitive complexity is still a complexity measure, but it attempts to map something that's a little more closely related to how coders view complexity rather than just the flow that the cyclomatic covers. The example in the paper gives two snippets of C code. One has two nested loops and a conditional inside of it, and the other is a switch statement, which is kind of like the match statement in Python. So they both have a cyclomatic complexity of 4, because the switch statement, you've got all those different cases, and that's kind of like a bunch of if-then-elses. But of course, the switch statement is far easier to read as a human because it's just a block. You look at it and go, oh, okay, it's going to go in, it's going to pick one of these, and it's going to come out. Whereas when I've got nested for loops and a conditional, now I'm like, what's the variable and how are they combined? So cyclomatic complexity here, it's gone up. It's equal in both of these cases, but these two things are kind of not the same difficulty to read. In fact, one of the criticisms of cyclomatic complexity is for larger code bases, it tends to correlate with the size of the project, which doesn't really tell you how much more difficult it is to maintain. So, by contrast, cognitive complexity breaks down into 4 pieces: nesting, structural flow, fundamental statements, and hybrids, which kind of mixed some of those. Using this earlier method on that for loop that I talked about before, the cognitive complexity of that for loop is 7, while the switch is only a 1. So this gives you an idea of, the switch isn't as hard to understand. So that was a bit of a long walk, but here now that we're here, complexipy, the library, computes this cognitive complexity on your code. It's got a bunch of different ways you can use it. I'll start with command line. You can just stick it and run it on a file. You can output the results to CSV or JSON, which makes it easier to connect to, say, a build pipeline if you want to consume it. And you can also set a flag so that it'll just exit and give up if you exceed a certain value, right? So if your complexity is a 5, screw it, we're not even going to keep looking. The docs have some great detailed examples on how to hook this up as a GitHub action as part of your CI/CD pipeline, and that's one of those places where you might use this max argument so that if somebody checks something in that is past your limit, then kill the check-in, essentially. Likewise, the docs also cover instructions on how to use it as a pre-commit hook, so there's plenty of choices. If that's not good enough, they also have a VS Code extension, which will give you real-time indicators of your code's cognitive complexity as you enter it, and it'll even highlight bad values as you go along. If none of that is good enough, you can still use it as a Python module. So then you can just call it as Python and plug it into whatever tools you have. These kinds of tools are very important at scale. We've got a lot of developers who are touching the same code base. It's useful to have standards and tools to make sure that those standards get adhered to. The cognitive complexity measure was introduced by the folks at Sonar. But if running a full Sonar cube is overkill for you, then this Python library is much smaller and handy to have around.
I dove into the subject pretty deeply with Rekha Horvath and Ben Martineau from Sorcery in episode 117. So if you want to go a little further along here, we dug into not only cyclomatic complexity and talked about that Sonar paper, the cognitive complexity. We also mentioned a PyCon presentation by Anthony Shaw about a tool he created called Wiley from a few years back, but still valid stuff, especially their tools at Sorcery are all about refactoring, which I think is an area where you definitely dive into this idea of like, okay, well, how can we simplify and improve our scores across these tools?
We also talked about it as the project called Radon, and a Mike Driscoll article on it in episode 176, and it covers cyclomatic complexity and a whole bunch of different ones as well.
All right. Well, thanks, Christopher, for bringing all these articles and projects and this mountain of news this week.
August will hit, and we will wish for this. Yes.
I guess so. We'll see. All right. Talk to you soon.
Cheers.
I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.